Hi, and welcome to the last segment in our first unit, shortly following our next hands-on class project, which will be designing a house, drawing plans to scale, and then determining the actual measurements of your rooms. So be thinking about that. Be thinking about a house plan that you want to use. We'll be going to a computer lab and using some software to create them. So you really do need to come with your idea in mind. So be thinking about that. But in this segment, we're going to use and discuss, I should say, inverse variation. If we recall, this is where one of my values increases and the second one decreases, and vice versa. If one decreases, the other one increases. And we can think about the number of workers. If we have more workers on the site, the number of hours needed to complete a project should decrease because we have more workers contributing. So we have our generalized equation, y equals k over x. Or we could use some simple algebra, and that makes it x, y equals k. And you can use either one of those in determining the constant of proportionality. So looking at our first example, number 17, we're given some values, some ordered pairs, and asked to find that constant of proportionality and then the generalized equation for this situation that's modeled, that would model this situation. So picking up and taking my ordered pair, first step says to substitute one ordered pair into the equation. And remembering I have y equals k over x, substituting 3 in for y and 6 in for x, I'm going to have 3 equals k divided by 6. The next thing says, next step, solve for k. So I need to eliminate the 6 in my denominator. And to do that, I am going to take 3 equals k divided by 6, and I'm going to multiply both sides by 6, making the 6's on the right side of my equation cancel, and I'm left with 6 times 3 is 18 equals k. So my generalized equation is going to be y equals 18 divided by x. Now, had we used our other example where we have x, y equals k, and this is usually the easier simplified version in finding k, we substitute x and y. I have 3 times 6 equals k. K equals 18. And my generalized equation becomes x, y equals 18. And both equations are equivalent. They are exactly the same relationship. All right, example 18 says to write a generalized equation for the statement, the current I varies inversely as R. So I varies inversely means I'm going to have some constant of proportionality divided by R, or the resistance. Using some simple algebra, I can multiply both sides by R, and I'm going to have R times I equals that constant of proportionality. Either way works. So, how do you suppose we do number 19? For the functions, determine if y varies inversely as x. If so, what's the constant? And then write the equation. So we're going to do the same thing, same process that we did when we were looking at direct variation. We're going to see if our constant of proportionality remains consistent. So I'm going to look at my pairs and see if my constant of proportionality remains the same all the way down the list. And I'm going to draw an extra column here, and I'm going to use the easy one where k equals x, y, and I'm just going to multiply straight across. 6 times 5 is 30. 10 times 3 is 30. Looking good so far. 1/2 times 60 is 30. And 2 times 15 is 30. So is this an inverse variation? Yes, because all my constants of proportionality for all the data is consistent and equal to 30. So writing my general equation, I am going to have y equals 30 over x, or, meaning the same thing, x, y equals 30. They are equivalent. Please pause the video and attempt example B. Determine if it is equivalent, if we have equivalent constants of proportionality, and if so, what is that equation? Pause the video now, complete the work, start up when you're ready to check your answers. All right, let's see how we did. Here I've got inverse variation and y varying directly as x. So I'm going to make another column, xy, and multiply across on my ordered pairs to see if that constant is equivalent. 40 times 1/2 is 20. 10 times 2, 20. 2 times 10, 20, and 60 times 1/3 is also 20. So, does this make it an inverse variation? You bet. All my constants of proportionality are the same, so it is an inverse variation. My equation is going to be y equals 20 over x, or x, y equals 20. If you're having difficulty determining that constant of proportionality, please ask for assistance or a few extra examples when we get together next time in class. There are several examples here, and I'm going to do number 20, and I'm going to ask you to do 21 through 23 on your own and bring that work with you to class. So 20. The heat loss through rock wool insulation is inversely let me start over, shall we? The heat loss through rock wool insulation is inversely proportional to the thickness of the rock wool. Makes sense. Heat loss is inversely proportional to the thickness, meaning the thicker, the less heat loss. The thicker the insulation, less heat loss. The thinner the insulation, more heat loss. That makes sense. So, if the loss through 6 inches of rock wool is 3,200 H per hour, find the loss through 2.5 inches of rock wool. My gosh, I'm having difficulty with that word. So, inversely proportional. So, I've got heat loss, I'm going to put L, is inversely proportional to thickness. Or L times T equals my constant. So using my ordered pair, it's telling me, giving me this information. 6 inches of rock wool is 3,200 I think it's BTUs per hour. We'll have to ask Mr. Kitzman in class when we get together, but I do think it is 3,200 BTUs per hour. So using this, I'm going to have 6 times 3,200 equals K. K equals 6 times 3,200 is 19,200. Writing my generalized equation, I'm going to have L equals 19,200 over T, or LT equals 19,200. They mean the same thing. Now that I have my generalized equation, it's saying go ahead and substitute in 2.5 inches for the thickness and how much heat are we going to lose. According to inversely proportional, we should lose more heat if our insulation is not as thick. So I'm going to have 2.5 heat loss equals 19,200. To isolate L, I'm going to divide both sides by 2.5. My loss, when it is 2.5 inches, should be more than the 3,200, and that is 7,680. And I do believe it's BTUs. Remind me to ask Mr. Kitzman per hour. Makes sense. Thinner insulation, we're going to lose more heat. Please complete problems 21, 22, and 23 and bring those solutions with you to class. Additionally, please do the self-check on our page on the Weebly site and print those results and bring them with you as well to our next class meeting. I hope you find ratios, proportions, and inverse and direct variations useful. I use it frequently in all situations in my life, actually. So please come with questions, and I hope you have a wonderful evening. Bye-bye.